All right, chapter 14 is about alcohols, ethers, and thiols, which are compounds that have sulfur in them. So the and alkyl halides. I forgot to talk about those. So, like I said, we're going to be talking about alcohols that have an OH group. It's also called the hydroxyl group, but pretty much it's an R group with an OH. Ethers are like alcohols, but they have two R groups on either side, or two carbon groups. So here are the general structure of an alcohol. You have an OH. Oh, um, let me get a pen here. There we go. An alcohol group is an OH, where an ether is an ROR group. All right, and like I said, we'll also be talking about thiols, which are groups that have a sulfur. It's like an SH. And then also alkyl halides, which are compounds that have halogens on them. All right, so alkyl halides and thiols. So alkyl halide, fluorine, chlorine, bromine, or iodine, and thiols is like an alcohol, but in place of an oxygen, you have a sulfur. All right, introduction here, just some everyday compounds that you see that have the, probably not everyday, um, as far as like these two, but in coffee, the classic coffee aroma is this compound right here, the 2-mercaptomethylfuran. Mercapto is kind of also another um, prefix for compounds that have a sulfur. It's not something that you're going to have to name per se, but if you see that term mercapto, that implies you have a sulfur on your compound. So that very classic coffee aroma is coming from this compound right here. Um, um, Enflurane is a compound that's kind of given as anesthesia just to kind of put you asleep initially, and it's a very halogenated compound. Um, you guys have heard of ether, all right? Ether has been used probably about 100 years ago, maybe 150 years ago, as to kind of put people to sleep or as a painkiller, but they found that ether itself is actually not very good for you. So when they halogenated it, they found that it actually clears out of the body very quickly and has very minimal amount of injury to the patient. And this compound, very complex compound, which is isolated out of the bark of a tree, is Taxol, which is an anti-cancer drug. So just kind of showing you all the alcohol groups on this compound plus an ether group. All right, so alcohols have what's called a hydroxyl group. All right, alcohols are classified by the number of carbons bonded to the carbon with the OH group. All right, so we will we talk about how to name alcohols, and pretty much your longest continuous chain is a chain that has the alcohol group on it, or the hydroxyl group on it. All right, primary alcohols are one that is attached to one carbon. So you've got essential carbon that has the OH group, and then only one carbon attached to the essential carbon. That's considered primary. So a secondary would be you have two carbons, and a tertiary, obviously, you would have three carbons attached to the carbon that has the OH group. Alcohols have a bent shape to them. Technically, they're a tetrahedral shape because remember we have these lone pairs here, so it kind of puts us in a tetrahedral shape. But if you ignore the lone pairs, you have this bent structure to it, 109.5. And alcohols are relatively polar because you have a dipole moment, because your oxygen has a partial negative charge. Your hydrogen here has a partial positive charge. All right, and your carbon over here has a partial positive charge. So you have a net dipole moment of going straight up. So it's a relatively polar molecule. Alcohols also form hydrogen bonding intermolecular forces, which we'll see cause alcohols to have relatively high boiling points for such small molecules. Okay, so all these properties give alcohols much strong intermolecular forces than alkanes in comparison to the equivalent alkane or alkene. So just to give an example, here is butane, a 4-carbon chain. You can see the melting point is incredibly low, minus 138, with a boiling point pretty much close to 0. So butane boils at 0 degrees. 1-propanol, I really won't want to focus on the boiling points because that has a drastic change. Notice it's 100 degrees, actually like 97 degrees of a difference. So the boiling point is much higher in 1-propanol, and that's because of the hydrogen bonding that occurs on your OH group. So because of the stronger intermolecular forces, you get a higher boiling point and melting point. Okay, alcohols are soluble in inorganic solvents. All right. However, if you have about, around that 4 to 5 range of alcohols, they will be soluble in water as well. All right. We've learned in lab it's about 4 carbons for every OH group. It all depends on the type of alcohol. You could push it to 5, 6 possibly. I've never really seen a 6 carbon alcohol soluble in water, but you're right on the edge there. All right, high molecular weight alcohols are not soluble in water, so pretty much anything more than that 4 to 6 range for every OH group that you have. All right, so ethanol, which is 2 carbons, is very soluble in water. However, octanol is not very soluble in water, more soluble in organic solvents. And we saw this when we did the solubility lab. Okay, naming. Pretty straightforward. Longest continuous chain that has the OH group on it. Okay, so this is our longest chain. And basically, you're going to start counting from the side closest to the OH group. So we're pretty much going to start counting right here at that carbon right there. Okay, so pretty much this is going to be called, let's see, 1, 2, 3, 4, 5, 6. So 5-methyl, 3-hexanol. All right, 5-methyl, 3-hexanol. And I'll go through the slides to kind of show you how you do it and the actual name. So step 1 is to find the longest chain that includes the OH group. All right, which are these 6 carbons. And basically, you're going to, when you take hexane, because it's hexane, you're going to drop the E and put an OL in place of it. So instead of hexane, you got hexanol. Number the carbon chain that gives the OH the lowest number, so basically the side that's closest to the OH group, like I said. And you'll have, and then you name any of the substituents, so 5-methyl, 3-hexanol. All right, pretty straightforward. If you have a ring with an OH group, the OH is always carbon 1. You do not have to tell the reader that that's carbon 1. It's just a cyclopentanol. Okay, so you don't have to say 1 cyclopentanol. It's assumed. So you name these substituents on whatever carbon they are based off the fact that this carbon is carbon 1. So this would be 2-ethyl cyclopentanol. Okay, so like here, the 1 is usually omitted. The ring is a number to give the next substituent the lower number. All right, so in this case, I have a cyclohexanol. This is my parent, cyclohexanol, and then I have a methyl group at the 3rd carbon. There are some common names for alcohols. Rather than using these IUPAC names, I'm going to go over a few of them. All right, name all the carbon atoms in the molecule as a single alkyl group, and then add the word alcohol afterwards. So instead of this being called 1-propanol, you just call it propyl alcohol. That's the common name, propyl alcohol. If the OH is on the 2nd carbon, so if you have this, which I believe is one of these examples, this is called isopropyl alcohol or isopropanol, which is rubbing alcohol. So propyl alcohol is where the OH is on the 1st carbon. All right, isopropanol or isopropyl alcohol is on the 2nd carbon, and we will see this as an example. But some other common ones are what's called diols or triols. That means you have 2 or 3 OH groups on your molecule. All right, so these are kind of common molecules, but this is 1,2-hexane diol. Okay, this is called 1,2-cyclopentane diol. Methanol obviously is a solvent. It is toxic when people do make alcohol, in particular moonshine. Even when they make alcohol in a factory, a good amount of methanol is actually created. However, they distill it and they filter it several times in order to get out all of the methanol. Obviously, if you make it illegally, you know, the moonshiners don't really take the time to actually, really distill out all of the methanol. Um, so one of the reasons with like moonshine is that it actually has quite a bit of methanol in it, and it can actually cause you to go blind if you drink too much of it. It's toxic. Ethanol or ethyl alcohol, obviously is alcohol, and alcohol is the alcohol in alcoholic uh, beverages. Also, it's the main alcohol that you get when you do ferment sugars, when you make wine and beer and spirits and things like that. Most of it is ethanol, but you do get a small amount of methanol as well. So here's the 2-propanol, which is isopropyl alcohol, which is rubbing alcohol. That was what I showed you in the previous slide. Ethylene glycol is a 2-carbon chain with 2 OH groups. This is one of the main components in antifreeze. It has a very sweet taste. They always tell you never let any animals into your garage, because if your car is leaking any of the coolant or the antifreeze, the animals for some reason are attracted to it because of the sweet smell and the sweet taste. And if they lick it and they swallow it, enough of it, they will actually die. It is extremely toxic. Glycerol is a triol. Um, so um, this is kind of the classic structure that people draw for glycerol. You have it's basically it's 2 carbons. So here's 1, here's 2, here's 3, and you got an OH on each of them. All right, this is kind of used as a lubricant. Okay, it's very lubricating, and so that's why they put it in lotions and liquid soaps and shaving creams. It also has a sweet taste. You guys have probably heard of nitroglycerin. Well, nitroglycerin is basically this molecule, but with NO2 groups right here. So this is what nitroglycerin is. Glycerol and glycerin are the same thing. So they have 2 different names, but they're the same thing. So that would be nitroglycerin. Some other alcohols that are interesting are carbohydrates. They are actually alcohols. They are, that's why it's called a carbohydrate. The hydrate is implying water. It's usually CxH2O, and then there's a certain amount of these for every carbohydrate. But it's basically alcohols. All right, so they're very long, alcohol containing and naturally occurring polymers synthesized by plants. All right, so starches is kind of the our main source for glucose, and cellulose is more fiber. This is what we consider fiber. And the bonding of it, we'll learn more about it when we get to the carbohydrate chapter. But amylose is a type of starch. This is kind of what breaks down into a simple sugar. You can kind of see this bond right here is coming straight down off of these 6-membered rings. These are what's called chair conformations. We don't talk too much about it in this class, but we might talk about it when we get more into the carbohydrate chapter. But you can see how you have this ring. It's a 6-membered ring. 1, 2, 3, 4, 5, 6. And then you have this bond going straight down and the oxygen, and it's hooked onto the next 6-membered ring. Okay, these bonds can break very easily when they are coming straight down. Okay, it's called the alpha linkage or the alpha glucose. Now, these oxygens could be, instead of it going straight down, it can come off on the side like that, which is what these are. So cellulose is where they come not going straight down, but straight out. It's what's called the equatorial position because it's around the equator. These bonds are much stronger. They do not break as easily. So that's what fiber is. Fiber is basically sugars that do not break very easily. Our bodies can't break them down. So that's kind of why fiber just kind of goes through us and it doesn't really get metabolized. All right, so I'm going to pause right there because we're going to start getting into our first chemical reaction with alcohols.